Alright, so in this video we are going to be applying some problem-solving strategies to a combinatorics problem, so let's get started. Alright, so getting started, we are going to first read the question. At a neighborhood basketball team, there is one person who chooses a committee of players to settle arguments randomly. The person who chooses the committee can't be a part of it. Every day, 8 students, so we have 8 students who play basketball, and one of them chooses the committee. So Brad chooses the committee, but Brad won't play. So we essentially have 8 people who play basketball, and our committee can be formed out of 8 people. So he'll choose it out of 8 people, essentially. That's what's going to happen. So Brad will randomly choose 3 players, right? So this is just 8, choose 3 to settle arguments and determine points throughout the game. Sadly, Lewis and Ben can never get along. Lewis refuses to be in the committee if Ben is in it, and Ben refuses the committee of Lewis. So basically what's going on here is we have to form, so 8 choose 3 is not the answer, but we're going to use it in the future in this problem. So essentially what's going to happen is we need to form a committee in which Lewis and Ben are not both. So we form a committee of 3 people. So we can have like Lewis, like some other person, and then some other person. But we can't have L, and then we can't have B. We can't have L, B, C, or whatever. We can't have this because we can't have L or B. We can't have Lewis or Ben in the committee. So this is acceptable, while this is not acceptable. So that's what we're doing here. So Lewis and Ben can never get along. So basically, how many committees can be formed? So first, we're going to use a different strategy. We know we're going to use combinatorics. We have a committee. Order doesn't matter. So we have 8 choose 3. Now, first, I want to ask you, how many committees are possible? And I want you, you're already set up here, and I want you to solve the problem. How many committees are here? We're not going to forget about the restrictions. Just tell me like how many committees can be formed if Ben and Lewis can be in the same committee. I want you to answer the problem. Alright, so hopefully you've come up with a solution to our semi-problem. We broke up our problem into several parts. And our answer is right on the annotations. It's 8 choose 3. We have 8 students, and the committee is formed by choosing 3, as we can see in this underline right here. So there are 8 choose 3 possible committees. But in reality, we don't want 8 choose 3. We can't have Lewis and Ben on the same team. So to fix this, first we're looking at the total number of committees, right? The total number of committees, if we assume that the total number of committees is like this entire box shaded, is the total number of committees that can be formed. But then remember, Lewis and Ben can't be in the committee. So essentially what we're doing here is if we count all the cases that we do not want, like we count whatever we don't want, like we count whenever Lewis and Ben are on the same committee, all we need to do is subtract it off from the total, and the remaining will be what we do want. So essentially what we're doing is we're counting the number of committees by taking away the restrictions, the number of committees that can be formed, and then we're subtracting off the cases that we don't want. And the cases that we don't want are any case where like LBC we don't want, so we just subtract it off. So we know we're going to be using some subtraction. Totally butchered that. And now we can just solve the problem. Now we need to develop another combinatoric. So we're going to need to have every single case that we don't want. Let's just think about this. We have our 3-person committee, right? And before anyone gets on this 3-person committee, we're going to put Lewis and Ben, right? We're going to put Lewis and Ben in. This is not allowed, but we're just doing it. Lewis and Ben are in. Now, once Lewis and Ben are in, they're all the way in. Lewis and Ben, they're in the committee. How are we going to develop a combinatoric? And pause the video in a couple of seconds around. 15 seconds, I'm going to give you my solution. Alright, so hopefully you've come up with a solution. We have 3 options for the committee. Once Lewis and Ben hop on the committee, we only have 1 more option for any other people, right? So once Lewis and Ben hop on, we only have 1 more option. For any other person come on here, we only have 1 more option. So essentially, if you have a committee and Lewis and Ben say they just come on the committee, we're only gonna have 1 option for another person to be chosen. So essentially, what's happening here is first we have A choose 3, and then we're going to subtract off the case we don't want. So LB, we don't want that. We don't want LB. So if I do like LBE, right now what this is basically doing is we have 8, but then Lewis and Ben got on, so this is 8 minus 2, which is 6. And then after that, well, there's only 1 spot, so this is just 6 choose 1. So what we've done here is Lewis and Ben get on. We only have 1 more spot, and this is the 1 more spot we have. And then now our 8 is Lewis and Ben make 2 people. 8 minus 2 goes over here. That's 6. So this is our expression that we are going to be using. So I'm going to erase all of this because that we don't need that anymore. We've solved the problem already. Now we just need to compute this, and we are done with the problem. So try to simplify these. I can't simplify A choose 3, so I'm just going to compute A choose 3. A choose 3 is 8 times 7 times 6 over 3 factorial. 3 and 2 cancel the 6. This is 56. 8 times 7 is 56. And then we subtract off 6 choose 1. 6 choose 1 is just 6. So our answer is 50. Because essentially what's happening is we've subtracted off the cases we don't want. So the remaining cases are the cases that we do want, which is 50. So that's how you would approach such a problem when it comes to combinatorics. Hope this video was helpful, and yeah.